Okay, good morning. After yesterday's big class on special right triangles, we followed up by two more really big classes. 8.5 and 8.6 is your formal introduction to trigonometry. 8.7 will be just a simple application of it. Here's your homework. You know the drill by now. All right, so tangent ratio. We're about to study something called trigonometry. And I mean, I really like trig. I find it fun. This is absolutely positively a calculator drill. So you're going to need your calculator. And in order to use your calculator correctly, I believe you had a TI, you need to hit the mode button. The mode button is in that second row from the top buttons there. It's black. It says mode. You need to hit the mode button and you need to make sure that your calculator is in degrees. Turns out by default, probably right now, your calculator is in something called radians. And you'll learn about radians in pre-calculus. But for algebra 2 and for geometry, we stick to degrees. So we need to make sure we're in degrees. So place your calculator in degrees. If you have any issues with this, you've got the different calculator, you can't figure it out, send me an email. I just want to make 100% sure that you have a calculator in degrees. So when you do all the work that's on this particular presentation right here, if you're in radians, you're not going to get anything remotely close to what I'm getting. So if that's an issue, I wouldn't even go to the end of the presentation. Send me a quick email. Let's make sure your calculator's in degrees. By the way, if you want to figure it all out yourself and you don't have a TI, just Google the name of your calculator and like how do you place that type of designated calculator into degrees. Guarantee you there must be a YouTube video showing you how to do that. All right, some quick background. So I said this is your introduction into trigonometry. So trigonometry comes from the word trig and metry. Trig means triangle and metry means the measure of. So we are going to be measuring triangles when we do trigonometry. Well, there's only two parts of a triangle. There are sides and there are angles. And trigonometry allows us to measure both of these. So measuring triangles is what trigonometry is all about. And for many students, maybe your parents, they did a full year of trigonometry. And I'll just say, as you get higher into math, trigonometry is used almost in every single problem you ever do. Why triangles? Why are they so important? Remember, all shapes can be made into triangles. Known shapes like a pentagon, weird concave shapes right there can be made into triangles. And even circles can be, well, they can't be made into actual triangles, but you can approximate circles with triangles. So today's going to be lots of new vocabulary. The more you use this vocabulary, the more used to it is. And by, let's see, by the end of the next lesson, you'll have this vocabulary down. So don't panic. They're just words and you'll learn them. So you're going to need your calculator today to do this class. Remember, trigonometry allows us to measure the sides and the angles of triangles. The big but here is that, once again, your calculator needs to be in degrees. Not that you can't do trig and radians. You absolutely positively will do trigonometry and radians when you get to pre-calculus. But for this year in geometry, we stick to degrees. All right. So make sure you're measuring in degrees. Fourth and final warning. So what are we doing? We're going to only deal with right triangles. Now, trigonometry can deal with any triangle, but for geometry, for the intro to trigonometry, we restrict ourselves to just right triangles. In algebra 2, you'll learn some trig for all triangles, but for geometry, they just stick to the basics, the simple ones. And you may have seen these buttons on your calculator too. So remember, we have other ways of measuring the sides of right triangles. Obviously, the Pythagorean theorem is the most important one, right? But you learned yesterday or last class, you learned the special right triangles. And so both the special right triangles and Pythagorean theorem can tell you the lengths of sides. Now, in order to use the Pythagorean theorem, you need two side measurements. In order to calculate the sides of a special right triangle, well, by default or by name, it's implied that they must be special right triangles. But what about a 10, 80, 90 triangle? And you only know one side. Well, that's why we have to have this other branch that gives us some help, and that's called trig. And I'm going to talk about these things called trig ratios today. Remember, ratio is a big fancy name for fraction. All right, so trig ratios. So trig ratio. Trig, once again, triangles, ratio, fraction. So I'm going to be dealing with the three main trig ratios in trigonometry. There are buttons on your calculator. You probably already noticed this. You just didn't know what they were for. So I'm going to introduce you now to your first new symbol in a while, and that's this symbol right here. So this symbol is a Greek letter. It's a capital letter, and in the Greek alphabet, they actually have a letter that represents the th sound in our alphabet. So we have two letters for th to make that sound, and like the sound in the word the. But in the Greek alphabet, they have one, and that is called theta. Now, quick note, that is not that symbol right there. Remember, we've used this symbol before, the one in the bottom left there. That is the empty set or the null set, and that simply means there are no answers to the problem. We say set like think of a bag, and inside the bag are all the answers, and our bag is empty, so we say it's the empty bag, except we say empty set. Null set means the same thing, empty set. So don't confuse theta with the empty set. All right. So it is a Greek letter th. This trivia here. If your name is Theodore, in Greek that would be Theodorus. This is how your name would be spelled. And notice the first letter there is a th. All right. So mathematicians, in algebra, we like to use x, y, z to represent the unknown number. We use that in expressions and equations. For instance, 2x minus 3 is equal to 9. Solve for x. In geometry, we like to use theta for an unknown angle. So when you're solving for an angle that you don't know how it is or what its measurement is, we like to use instead of x. Now, you're going to see that our book uses both x and theta all the time, and they use them interchangeably. If you notice, if you have that TI calculator, if you look on your calculator where the X, the button you've been using many times, that X button right next to it, the same button, it's not just the X button, it's the X, comma T, comma theta, and I believe there's another one as well too. Let's see, do I have a calculator? Oh yeah, here. So it goes X, T, theta, and N. And all of those just represent unknown variables. X for the common one for algebra, T for time, theta for an angle, and n for a number, usually a number in a sequence. But long story short, even though it's one button, there's four labels on it, it really just means a variable. And the variable could have been any one of those letters. You could use those in algebra or geometry. And we will be using theta both in equations and expressions today as well too. So for instance, if the measure of angle A is 30, but you didn't know how big it was, you could say an unknown measure of angle, how big is the unknown angle, and you might solve it for 30. So replace x with theta. That's how it works. All right, back to our main task. So trigonometry can work with all triangles, but some trig only works with right triangles, and that's the trig I'm about to tell you or teach to you. So trig this year only deals with right triangles. Algebra 2 and better, I mean pre-calculus, calculus, we're learning other trig for all triangles. All right, so I said some more vocabulary, some new names. Here we go. So the sides of right triangles, well, if we're dealing with Pythagorean theorem, that's a and a b and a c. We're going to give new names to them. So here's how this works. So you have to first off, you have to have a right triangle. Notice that's right triangle ABC. The right angle there is B. And then you have to pick one of the angles that is not right. So that's either angle C or angle A. And since there's no labels there, well, then we don't know how big angle A is, or angle CAB, or angle A. And so therefore, I'll put that theta there to represent the unknown angle. Now, as soon as I do that, as soon as I say, how big is angle theta or angle A, then the three sides get names. Once again, the first thing that has to happen is you got to pick angle A or angle C and have theta represent that angle. So the three sides are going to get new names. Now, one of the sides is going to get the standard name. The side that is always opposite the right angle, that's the side that's opposite angle B, that is still called the hypotenuse. So we'll still call that the hypotenuse. But the other two sides we used to call legs, and they're still called legs, but in trigonometry, we give them special names. The side that is directly next to theta, directly next, in fact, it's the side that makes angle theta with the hypotenuse, is called the adjacent side. Now, make sure you look at that geometry right there. So if you combine the hypotenuse and the adjacent side, you make angle theta, or angle A in this case. That leaves one side left, and that's the side opposite angle A or angle theta. And you guessed it, we're going to call it the opposite side. So I didn't say that these names would be that challenging, but there are three names here. So in trigonometry for right triangles, we pick an angle, not that 90-degree, but either one of the other two angles, and then we give three names to the sides. The hypotenuse is always the hypotenuse. The side that is directly next to angle theta, that's not the hypotenuse, is called the adjacent, and the other side is called the opposite. Now, you might have already figured this out, that what would happen if I picked angle C. And this is the but here. So if I pick angle C instead, well, that's going to change two of each sides. The hypotenuse is still going to be the hypotenuse, but the side that we formerly called the opposite, well, now it's next to theta, so that's called the adjacent now. And the other side is called the opposite. So make sure you understand that. If you need to rewind and watch that little presentation again, do that. Make sure you understand how you determine which sides are opposite and adjacent. Hypotenuse always remains the same. So if you can handle that, you can do some trig. You also have to be able to press some buttons on your calculator. And I encourage you, as you press these buttons on your calculator, before you hit or after you hit the enter or the equal button, to look at your screen and make sure that you typed in exactly what you want to type in. It's really easy to mess up punching the numbers into your calculator. All right, so if you can label a right triangle with opposite and adjacent sides and hypotenuse, and you can punch some buttons on your calculator, you can do trig. All right, for this year at least. All right, trig can get really complicated, just not this year. So what were we doing? We were going to be measuring unknown sides and unknown angles. So we'll start off with one of those. So we'll start off by calculating the length of the sides of a right triangle without using Pythagorean theorem or special right triangles. So we're going to use these things called trig ratios. And these are just definitions. By definition, we define a specific fraction to represent two of the sides of a right triangle. So without further ado, let's do that. Ratios are formed by the right triangle sides and angles. There are many of these. We're only going to learn three of them this year, and these are the three basic ones, and they are buttons on your calculator. You may have noticed that. These are lots of the trig ratios that you're not going to learn any of these this year, but going forward, there's lots of trig ratios. In fact, I mean, lots and lots and lots of these things. In fact, this is basically what pre-calc is all about, is this slide right here. But this year, you're only going to do three of these. So where do these by definition come from? Well, let's go back a couple chapters to similar right triangle or similar triangles in general. So here are two similar triangles. How do I know they're similar triangles? Remember, we have three ways of showing triangles are similar: SSS, SAS, or angle. And if you notice, these two triangles are right, so there's one angle, and they're already labeled right there as the angle 37. So these two triangles are similar. And what was one of the so what's about similar triangles, at their sides can be written in a proportion. So in other words, if I go to the small triangle there and I write the ratio 3:4, and the two triangles are similar, then the consequence of the two triangles that are similar is that the other triangle, if I put their sides in the same ratio, basically I'm doing left side over the bottom side, well, then they have to be the same ratio. And what do you mean the same ratio? 3/4 is not 9/12. Oh, it is if we reduce 9/12. So this would work whether the triangle was larger or smaller. And that this is the power, and the trig ratio would not change. The numbers would change, but the values: divide 3 by 4, you get 0.75. Divide 9 by 12, you get 0.75. And that will always be true no matter what the triangle is, as long as it's similar. That if you have angle 37 and you put the left side over the bottom, then you're going to, and notice using the right words here, opposite over adjacent, we would in fact get 0.75. All right, this has huge consequences, and basically what it says is that, think about this: if I have a ratio right there, I can erase one of the numbers and I can solve for an unknown side, but I would need to know that the angle was 37, and I would need one other side. So one thing that trig does for solving for sides allows you to solve for any side as long as you know one angle and one side. So before calculators were invented, people did this all by hand. They had these things called trig tables. If you look down there on the left one right there for 37 degrees, if you look at the trig, notice it says, now it's rounded, 0.75. All right, so back to remembering how to name. Remember the side that's opposite angle theta is called the opposite side. The hypotenuse is the side opposite the right angle, and the adjacent side is the one next to theta. All right. So we're going to write this down. By definition, this is not anything that's proven. Just someone said we are going to call, once you define the angle. So you pick the angle. In this case, we picked angle A. That's your theta. We were going to find the ratio of two of the sides, and the two they chose were the opposite and the adjacent. So by definition, that's the ratio, and they gave it a name, and they called it not tan, although that's the button on your calculator. All right. They called it tangent. All right, so I'm going to give you a moment to write this down. Notice this isn't a theorem. We didn't prove this one. This one is just a definition. So today we're just doing tan. If you notice, you may have noticed that button on your calculator. There's two other buttons right next to the tan button. We'll do those two buttons on the next class. But today is just tan. Allows you to fully wrap your head around trigonometry. All right, quick note. So the tangent of alpha or theta here, right, would be the opposite over the adjacent. And if we think of that as the side lengths of that triangle, let's see, the opposite side would be CB and the adjacent side would be AB. That would be for angle A. But remember, I could pick angle A or angle C. So if I pick angle C, hypotenuse stays the same, but I got to switch the opposite and the adjacent. So I would get a different ratio for tangent C. So tangent C would not be CB over AB. It would be that fraction reciprocal. So the opposite turned into the adjacent turned into the opposite. And so it's not surprising that just flipped that fraction around. Now, nothing to memorize here. I'm just pointing this out. And if I spoke too fast there, rewind, listen to that one again. That one's important. So what can I do with this? How does this all work? So we're just going to be playing three games today. The first game accomplishes nothing. As usual, sometimes in math, we just do a setup of a problem. It doesn't actually solve for anything. So the first thing we're going to do today is just do a setup. And that means we're just going to write the ratio. We're not going to be solving for a side. They just want to make sure that you can actually set the ratio up before you grab your calculator and make a mistake. So they're going to give you a triangle. These are the first couple ones for homework. They're going to give you a triangle, and they're going to give you an angle. I mean, they're going to give you that. They say, what is tan y? So here's how this works. Well, you got to find angle y. Angle y, since it's tangent, will be the ratio of opposite to the adjacent. So there's angle y. So I'm not saying you have to circle and label these things, but you can if you'd like. Let's see, the opposite side would be 5. And the adjacent side, be careful because we don't want to use the hypotenuse. The hypotenuse is the side opposite the right angle. So the adjacent side would be 12. So that's why tan y is 5 over 12. And if you were paying attention, the very next question will probably be, what is tan x? And if you were paying attention, you don't need to do any work. You could just write the reciprocal of that fraction, but let's go ahead and let's do it normally. So we know tan x is the opposite over the adjacent. So there's angle x. So the opposite side, be careful, not the hypotenuse, is 12, and the adjacent side is 5. And so there's your ratio. Now, what did we accomplish? Well, pretty much nothing there. We didn't solve for how big the angle is or even an unknown side. We just set up the ratio itself. So that's not a big deal, but it is a big deal because as soon as we actually solve for an angle or side, if you can't set up the right ratio, you don't get to the right answer. So what's the big deal about trig ratio? Remember, all similar triangles have their sides in a proportion. Therefore, I don't care if the triangle is large or small. If the angle is 37, you're going to get 0.75 each time. And how can we make that useful? Well, that means I don't need to know two sides. I just need to know one side. And I can solve for the second side just by setting up a little expression and solving it. Because remember, 3/4 is 0.75 and 9/12 is 0.75. So I could erase the 3, I could erase the 12, and I could solve for that unknown angle because I know the answer must be 0.75. What your calculator does is it knows that the angle 37 is associated with 0.75. All right, huge consequence. This idea allows you to calculate the side lengths of right triangles, but you must be given one angle and one side. All right, so here's the first real game, right? Well, the first game they have you play is just set up the ratio, but the first time that you're actually solving for something, we're going to be solving for an unknown side. Now, remember, we have other ways of solving for unknown sides, Pythagorean theorem, but you need to have two sides to do that. If you can do it with a special right triangle if you have one side, but that only works for special right triangles. So trig ratio works for any right triangle as long as you have one side and one angle. So if you need an example of this because you're a little bit confused, here we go. So notice here's a right triangle, and we're given one angle and one side, and we're asked to solve for a second side. That's the angle of the side y there. So it seems like magic that this can be accomplished because all you know is one side and one angle, but it's not because we have similar triangles. And all triangles that have an angle, or all right triangles that have an angle of 56 will have the same ratio. Whether it's a large triangle with 56 or a small one with 56, you'll get the same ratio. So here's the setup. So the only trig ratio we know right now is tan. Tomorrow we'll get two more. And we know that tangent of theta is equal to the opposite of the adjacent. So step number one, circle the angle. So that would be angle 56. Figure out what the opposite side is. The opposite side is y here, and the adjacent side is 32. So tan 56 is equal to the ratio of y over 32. So y is the unknown. And now it literally is just an algebra problem, solving for y. So where is y? The right side. What's attached to it? 32. How is 32 attached to y? Division. We get rid of division by multiplication. The 32's on the right side cancel, and we're left with 32 times tan 56 equals y. Grab your calculator, because what are you going to do? You're going to use your calculator and literally do 32 tan 56. You do your calculators, you don't even need to put a multiplication symbol, although there is one between 32 and tan 56. You can if you want. In most calculators, if you have a TI, this is true. Most calculators, when you hit the tan button, it says the word tan, and it opens up a left parentheses and a blank. You type in 56. And yes, you're supposed to close your parentheses, but you're going to find out that most calculators don't even require that. So go ahead and punch that into your calculator. And if you did it right, it's going to be a long decimal number. We're going to round. I believe for homework, they either say round to the nearest one decimal place or to the nearest whole number. I'm not sure which one. But if we round ours to the nearest decimal, we get 47.4. So that's the length of y. And that's what trig is like. All right, one more. I got a right triangle. I got one angle, I got one side, so I can solve for a third side or second side. So let's see, tan 42, and remember tomorrow we're going to have our choice of three different ratios, but today we can only do tangent, and tangent is always opposite over adjacent. So let's see, tan 42 is equal to the opposite side, which will be x, over 12. The adjacent side is 12. Okay. Let's see, where's x? Right side. What's attached to it? 12. So that means multiply both sides by 12. The 12s cancel on the right side, and we're left with 12 tan 42 is equal to x. Grab your calculator, and away you go. If you did it correctly, you should get 10.8. Now you can do a little bit. I mean, it's an estimation check. Let's see. We're looking like it's about 11, and yeah. I mean, you'll when this goes bad, it goes bad really really quickly. Negative numbers if you're in radians. You can also get a number that's not even remotely close to 12. For instance, if you got 4,600 or something like that, you would know for sure that you've done something wrong. Your calculator doesn't love you because it will tell you anything it wants to tell you. So if you hit the wrong buttons, your calculator will happily spit out a wrong answer. All right, so hopefully you got a good taste of that right there. If not, back it up and do those two examples again and make sure you're getting the right answers. All right, so here's a more challenging example right here. So, I mean, it looks like the same basic thing. I got an angle, I got one side, but notice what happens this time when I set up the tan. So let's see, tan 15, the opposite side would be 14, but this time the adjacent side would be x. And notice the x is on the denominator instead of the numerator. So this is just algebraically, it's a little bit more complicated. It's not a hard example, it's just a bit more complicated. Whenever you have a variable in the denominator and you want to solve for that, always multiply both sides by the denominator. And then why would you do that? Because look what happens on the right. On the right there, the x's would cancel. So I would be left with this. And I'm trying to solve for x. Notice it's x times tan 15. To get rid of multiplication, you divide. So I divide both sides by tan 15. On the left side, the tan 15s would cancel. And so I would be left with x is equal to 14 tan over tan 15. Grab your calculator and away you go. Now, remember, if you're using that TI and you have one like mine there, you can hit the green button and the X button to get a fraction to pop up. You don't have to. You can if you want to. You can also just do 14 divided by tan 15 and you'll be fine. So we're looking for a side length. It better be longer than 14, and it's 52.2. And just eyeballing it, that looks like a reasonable answer. So this one was just algebraically slightly more complicated. So let's do that again. All right, different problem. Right triangle, one angle, one side. We only know tangent. It must be tangent today. Tomorrow it could be sine, or the other two that I'll teach you tomorrow, or tangent. So the opposite side is 13. The adjacent side is x. X is on the bottom. So the trick is we multiply both sides by x. The x's cancel on the right side. Divide both sides by tan 37. Tan 37's cancel on the left. So x equals 13 over tan 37. That's what you'd plug in your calculator. 13 divided by tan 37, which gives us about 17.3. And that looks like a reasonable answer. All right. Trig is way more powerful than just sides because it will also calculate angles, but it uses a different key. So we can also calculate unknown angles, but we're going to use a different button on our calculator for that. All right, the button here is, in order to do this, you got to have two side measurements. Now remember, we're solving for an unknown angle, so you're not going to know any angle other than it's a right triangle. So how does this work? Quick reminder of inverse operations. Remember, for algebra, the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of squaring is square rooting. So what's the inverse of tangent? Well, if you look at your calculator, find the tangent button, and don't look at the button directly above it. Look what's written above the tangent button. Written above the tangent button is tan to the -1. Now, that is how we write inverse tangent. Inverse tangent, or the inverse of tangent, is written as tan to the -1. So it's going to look like that. That's your inverse. So what do you use inverses for? To get rid of what you did in the first place. So if you add 2, how do you get rid of add 2? You subtract 2. If you square something, how do you get rid of the squaring? You take the square root. So if you take the tangent of something, how do you get rid of the tangent? You do the inverse tangent. Now this will make a total sense here once we do the problem. So inverse tangent undoes the tangent function. So here's what the problem will look like. You got a right triangle. You have two side measurements. I can use Pythagorean theorem to calculate the third side, but I don't want the third side. I want to know how big is angle A. Notice that X there. So here's how it works. Step number 1, the angle X. Well, angle X, the tangent of it, right, would be equal to the opposite of the adjacent. Look, the opposite of the adjacent is the same value. So that would be 3 over 3. Now, I want to know how big angle X is. Angle X is on the inside of that word tangent. So I want to erase the word tangent. I want to do the inverse of tangent. Now, remember, whatever you do to one side, you have to do the other side. So to get rid of the word tangent, we do the inverse tangent of both sides. So the inverse tangent and the tangent cancel each other out, and you're just left with X. And on the right side, it literally says inverse tangent of 3 over 3. Guess what? That's what you plug into your calculator. Now make sure you're doing inverse tangent. Watch the screen as you're doing this. So on my calculator, you hit second, and then you hit the tangent button, and up pops inverse tangent. Do 3 divided by 3, hit enter, and it will tell you that now, once again, it'll be a decimal. In this case, it's going to give you right exactly 45, but most of the time it'll give you a decimal answer. All right, so that's how you solve for an unknown angle. Here's another one. Now, why is that number over there a weird number? Now, remember, most of the time when we were solving for sides, we were getting a decimal answer that was very long. We had to do some rounding, so it's not surprising that if I plug in that number, what I'm really trying to do is trying to make x to a nice friendly whole number when we solve for it. So it would not solve. If I just did a 47, you would get another decimal answer. So watch what happens. All right, so let's see. Tan x would be equal to the opposite over the adjacent. I need to solve for the x there. So I do the inverse of tangent, which is inverse tangent of both sides. On the left side, if you take the inverse tangent of tangent, tangent and inverse tangent cancel, and you're just left with x. And on the right side, it says inverse tangent of that big ugly fraction. Type that into your calculator, and you'll figure out how big angle x is. So I got roughly 50. I believe it just rounds to 56. So when you do your homework tonight for both sides and both angles, be ready for most of your answers to be decimal answers that you need to round. Usually, if I remember right, they want you to round the angles to the nearest whole number and the sides to the nearest tenth, something like that. All right, one more. Let's see. I got a question mark there, so that must be my unknown angle. Look, they gave me all three sides there. So when they give you all three sides, make sure you pick the two that you need. So in relationship to the question mark, the opposite and the adjacent would be 72 and 21, not the 75. The 75 would be the hypotenuse. Tomorrow we learn our last two trig functions. Those are going to deal with the hypotenuse. But for today, tangent only deals with opposite and adjacent. So how do you get the question mark? You take the inverse tangent of both sides. Inverse tangent cancels with tangent, and you're left with question mark is equal to inverse tangent of 72 over 21. And if you've been paying attention, maybe you notice that we could probably save ourselves algebraically all those steps just by jumping to inverse tangent of opposite over the adjacent. And that's what most students do once they understand this pattern. It seems like that step there of canceling is a waste of time, since you're going to know that it's going to be the inverse tangent of opposite over the adjacent. So you are free, once you realize this, to immediately, you're not jumping to the answer, you're just jumping to the calculator portion of it. So the inverse tangent of opposite over adjacent will give you the angle. So we grab our calculator, toss that in. I got 73.7 approximately. All right, I'm going to add one extra step. There's one or two problems tonight for homework that add some complexity to it. Here we go. Let's see. Oh, crud. Look, I got a triangle. The only trig ratio I know is tangent. Tangent requires me to use opposite over the adjacent. I don't have the opposite. I've got the adjacent, but I do have the hypotenuse. Tomorrow we'll learn a new trig function for this, but today all we know is tangent. So if they give you two of the sides, but you need the third side, well, we got to reach back to our friend Pythagorean theorem to find the opposite side. So if you know two sides, you can find the third side with Pythagorean theorem. So let's see, that would be 7 squared plus b squared is equal to 26 squared. Just a calculator drill. Grab your calculator, do the Pythagorean theorem, subtract 49 from both sides, and then take the square root, and you get about 25. So I know the opposite side now, the side that I needed, was roughly 25. So I'm going to toss that into there, take the inverse tangent of both sides. If you know how this drill works, as soon as you know the opposite of the adjacent, you can just type that directly into inverse tangent and skip that step that I just did there to get to your final answer of 74.4. And there you go. So welcome to the club. You now know a little bit of trig. You know just enough to be dangerous. Most kids at this point wonder why in the world, when will we ever use trig? Okay, this was a far-reaching, example. So early Middle Ages, before the invention of, or before the Europeans used gunpowders to knock these walls down, they used mechanical siege devices. One thing was called a trebuchet. So a trebuchet throws big, heavy rocks. So the people that operated these things would know how far they could throw the rock. But the problem was they would not know how far the castle was from the trebuchet. So it was really important for them in order for them to get the rock thrown the right distance, for them to know that distance. And they certainly wouldn't want to walk between the trebuchet and the castle, because there's people on top of the castle shooting arrows at you. So one way, and this is literally what they did, was they would go left or right at a right angle to the trebuchet, say for instance 500 feet, grab a protractor and measure that angle right there. So let's say it's 56 degrees. Now they know exactly how far the trebuchet is to the wall. They just use the tangent function. And they literally would know, granted, they didn't have a calculator, so they were doing this by hand, but they would get a really smart person who could do long division and multiplication very quickly in their head or on paper, and they would do the tangent. So they could figure out how far the trebuchet was to the castle just by using tangent. It's pretty nifty, right? So now they know the trebuchet is 740 feet away. So they would know how much weight to put into their trebuchet in order for the rock to travel 741 feet. And they could make they could hit the castle wall within a shot or two simply because they knew how far using trig how far it is away. Okay, so that's one of many examples of how trig could be used. All right, so here's your homework. Once again, good luck. If you run into problems, send me an email. I'll get back to you as quickly as I can. Hopefully, you're not having any issues, but if you are, as always, send me an email.